virtualization is not a 15-year-old technology. It is not 20-year. It is not 25-year. It is very, very, very old. See, 1968. Okay, that time on an IBM mainframe computer called CP40, IBM introduced a memory virtualization concept. That means if they have a 8 MB of RAM, they can run programs which is of 16 MB or 24 MB, right? Whatever is RAM available, they can run programs which is bigger than the physical RAM available. That is what they introduced. That is called memory virtualization. That was in 1968. And it was a specific vendor. They developed it and they were using in that product, and because of that, not much external people were aware about it. And later, people when they started learning about the IBM mainframe computers and all, people realized that okay, there is something called a memory virtualization. It is good, less RAM, but I can make it utilize like I have more RAM. Then different people started thinking, why can't we use this concept in other places also, in other resources? And that is the time different people, different companies, different vendors started working on developing this concept into other resources. And that is the time we started reading in magazines and all saying that okay, there is something called a virtualization. It is good. We can save money. We can improve the utilization of resources and blah 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 blah. Okay. And what we say today is the number one vendor in virtualization technology is VMware. Right? See,
Yes.
that company itself is formed in 1998, but the technology is before that. And other main player is Citrix. That company is formed in 2007 only, but the technology is older than that. Okay, so these companies, they took this product and they developed by adding their own different features and all. That is how they developed their products and they came into the virtualization field. Okay, so that is about the history of virtualization. Now, coming to the main players in virtualization, these are few. There are so many vendors in virtualization. These are the few companies. Citrix is one. VMware, KVM. KVM is a Linux-based virtualization. Parallels. Microsoft is there. Open VMs and Open VZ. So many vendors are there. So just to know few. Okay, these are the vendors. Now, why VMware? So why we need to learn VMware? Why not Citrix or why not Microsoft or something else? Okay, this is a little old graph, but still some changes are there, but still major player is ESXi, that is a VMware. So if you look into the market share of different vendor virtualization product, ESXi or the VMware, ESXi is a VMware virtualization platform. ESXi is having the major share in the market. So of course, when a product is having more demand in the market, if you learn that product, then we also will have more demand in the market. So this is why people are going behind VMware technologies. And compared to other vendor products, of course, VMware is having more features, more reliability, more stability. Okay, of course, people will be going behind those kind of products only. All right. Now, coming to the VMware different training programs for virtualization. This is the information. So we have actually 4 level of training programs available from VMware on virtualization technology. One is associate level. We call it as VCA, VMware Certified Associate. In that, different tracks are there. Like CCNA, we have routing and switching, storage, data center. Different tracks are there. Similar to that, here also VCA, there are different tracks. Desktop is there, mobility is there. And professional level, that is a second level for the certification, which is called VCP, VMware Certified Professional. On that level also, we have different certifications available. Okay, VCP, DCV is there, VCP NV is there. DCV stands for Data Center Virtualization. That is what we are going to discuss. VCP NV is Network Virtualization. That is the NSX. That is our next section. Okay. Then the third level of certification is VCAP, That is the advanced professional certification, VMware certified advanced professional. In that level also we have multiple tracks. Then the highest level is expert level. It is like similar to CCIE. It is VCDX, VMware certified design expert. Here we will learn how to design data centers using VMware products. Okay. These are the different level of certifications available from VMware. What we are doing is the professional level. Associate level, there is not much. They introduced the associate level certificate recently, and this is not a serious certification, so no one is giving extra care into the associate level certifications. We can go directly to the VCP. So we have what we are going to discuss is first sessions will be on VCP DCV, that is a ESXi virtualization part. And the second session will be on VCP NV, that is the network virtualization NSX part.
Okay.
All right. So now what we are going to discuss today is these things. We will see what is a data center. Then we will see what is the problem with the traditional data centers. If there is no problem, then no one will make a change, right? There were some problems in traditional data center. That is the reason we came up with virtualization. Then we will see, because of virtualization, what is the advantage we got. And we will see what are the extra features we are getting because of virtualization. This is what we will discuss today. We will get an overall picture about the virtualization concept. That's the section I planned for today, and we will stop it after that. Okay. This is a representation of your data center. This is the architecture of a data center. So majorly we have few components. You can see here, this is your storage. So what is a data center actually? We have a centralized place where all our critical applications will be running, and those executed applications, they will use some data. Those data will be stored in some storage device. Whenever it is required, the servers will be storing data into storage device, and they will extracting from there, and it will be executed on a server. And when a user demands it, he will provide the information to the user. So we have a server, we have storage. So those are normally two separate components in data center, and we need a connectivity between them. For that, we use network. So we normally see two type of network in data centers. One is our normal data network. That is what it is mentioned in the diagram as a LAN and WAN. On the right side and left side, you can see LAN and WAN. That is your that connectivity between these servers and end users are sitting on top. Okay, so between them, what we see is the normal data network, and below bottom you can see the servers, mail server, application server, database server, and below you can see the storage. In between the server and storage, what we see as SAN, that is your storage network, storage area network. So we see normally two type of networks inside your data center. The top part is your users who is sitting and accessing the resources and getting doing some task and getting the result and utilizing it. So this will be your data center structure. This is the core data center components. Now, on addition to this, we need two more things. One is power. That will be the external component for the data center, which is mandatory for your data center. So power sources for data center normally we call it as power grids. Power grids are redundant power sources are called power grids. So whenever we give power, even if one generator or one power goes down, we will have a redundant another source to give power to the data center. So power is another resource requirement for data center. And the second one is your cooling system, AC. Why we are using AC in data center? The reason is the servers are critical resources for our data center. And these all servers have something called CPU and RAM. These are semiconductor devices. The semiconductor devices behavior will change depends on the temperature. If the temperature goes high, the expected result cannot be produced by these devices. So when we use these for mission critical applications and the servers are producing wrong result, that is not an acceptable thing. So that is the reason to keep the servers on controlled temperature and get the expected result, we are using cooling system, ACs to the data center. So the temperature will be maintained and the servers will be kept in particular temperature and the expected result will be produced. What happens if the temperature goes high? The servers will be designed in such a way that if the temperature goes beyond a particular temperature, it will keep on restarting. So what they think is, it is better to stop the server than giving a wrong result. That is how the servers are designed. Okay, so this is the overall structure of your data center. Any question here?
Yeah, nothing.
Okay. So I think these all you're already familiar, right?
Yes.
Okay. Okay. So this is a data center, looks good, but we may see something like this also in some places, right? So just for fun, I just added this one, but this is a fact. In some places, we can see messy data centers also.
Yeah.
Now, coming to the problems of traditional data center. What are the problems? One is time-consuming provisioning. What is mean by provisioning? When a customer coming to us, for example, let's assume that I am the owner of a data center. One customer is coming to me. So the time I collected the requirement from him, once the order is confirmed, the time taken to provide the service to the customer is called provisioning time. So on a traditional data center, how it is normally happening is, when I get an order, I will see the resource requirement. And in traditional data centers, how we used to do is, we used to give dedicated hardware to each and every customer. So when a customer coming and he says that, okay, he need a server, now I will find out what is the resource requirement and which server is suitable for that. Then I will identify the vendors who can provide that particular specification server. Then I will place an order. That vendor may take some time to deliver it to my data center. Then I will make some provision in any of the rack for keeping this server. I need to give the power provisioning. I need to do the network cabling to that. And I will place the server in the rack. If free rack space is not available, I need to get a new rack. Right. Once the servers are placed in the rack, then I need to install the OS, do the patching. I need to install the applications. I need to do the configuration for the application, then test it. Then only I can give a service to a customer. So these all process will take a long time. Assume we took some 2 to 3 weeks time for doing all these things. Okay. So this much time. What happens if another vendor, my competitor, approaching the same customer and saying that we have servers spare available in my data center, and you give me the order, I can give you in 2 days. What will happen? I will lose my business. So that was one problem in traditional data centers. Time consumed for provisioning is too much. Okay, that was one problem with the traditional data center. Second is high hardware cost. Obviously, when I have multiple or separate hardware given to each and every customer, my cost will be high. Even if I give multiple hardware, there will be some resources not utilized, but I cannot utilize that to another customer, because one dedicated hardware to one customer. That was the older concept. Then higher cooling system requirement. That means I need more AC. Why I need more AC? Because I'm having more hardware. More hardware produce more heat. I need more ACs. That is another problem. Then high power consumption, of course. I have more hardware, more AC, I need more power. Space consumption. More hardware, obviously more space is required. More carbon footprint. So that I need not to explain, right? Carbon footprint is all electronic equipments will produce chlorofluorocarbon, which is harmful for our ozone layer. So when we run more hardware, actually we are increasing the carbon footprint and we are making damages to our life itself. Then vendor lock-in. What is meant by vendor lock-in? Assume a customer coming and saying Solaris OS is required. Which hardware we need to purchase?
Spark.
Yeah, Spark machine, right? We cannot go for any Intel hardware for running Solaris. I think recent versions supports Intel hardware, right? If I'm not wrong, is it? Any idea?
I won't support it.
Okay, you don't support. Okay. So as of older days when I worked Solaris, it was on Spark only, but somewhere I heard it like that. It is not wrong. It's not correct. Okay. All right. So vendor lock-in means there is some situations in which I need to go and approach one particular vendor itself. I don't have any choice. So when there is no choice, I purchase one hardware for my customer and I'm setting it for giving a service. One particular hardware is not enough. What happens if that hardware crashes? I cannot tell my customer, okay, your hardware crashed, so give me another 3 weeks to set it up. I need to go for a alternate hardware also in my data center. So that is the problem when we have specific vendor requirements. So this is a vendor lock-in problem. Now coming to underutilization of resources. That is, everyone knows it. Even if you take your laptop, we have nowadays 16 GB of RAM, 2 TB of hard disk, and CPU of 4 core, 8 core, right? But when we look into the resource utilization anytime, CPUs are normally less than 10%. Normally, if you are not running any heavy applications, it will be 10%, less than 10%. And your RAM utilization somewhere around 2 GB, 2.5 GB. And your hard disk utilization, initially it will be somewhere around 30 GB only, but you have around 2 TB of hard disk. That means we are spending 1 lakh rupee for a laptop, and I'm using approximately 10 to 15% of that amount. That means 15,000 I'm utilizing. Remaining amount 85,000 rupees is a dumb investment. I'm not utilizing those resources in most of the time. The same is happening with your server hardware also. We are spending lakhs for the server, but the resource utilization is less. Maybe servers may utilize somewhere around 20 to 25%. That's it. In measure of time. Whenever some high load is running, then it may go high. So these all are the problems with the traditional data centers. So then different people started thinking how to resolve it. This is another reason why virtualization they develop for different resources. Okay, so now let us see what is virtualization. Now this is a text definition. Okay, I don't want to go into those text-based definitions. So basically what virtualization does is, whatever resource is available with us, what we do is, we will split it. And a pool of resources, when we split it, I have CPU, RAM, hard disk, 3 resources majorly we utilize in servers. So a pool of RAM, CPU, and hard disk will be given to one customer. So assume that is utilizing some 10 to 15%. Still have 85%. I'll make another pool and I will get to second customer. So total both pool together or both customer resources together, it will go approximately 30%. Like that, I can make multiple pools of resources and give to multiple customers. So how do I give to the multiple customer? These resource pools which I created will be conceptualized as a virtual computer, virtual hardware. We call it as virtual machine in virtualization field. So we create virtual machine. Virtual machine is actually a software constraint which behaves like a full-fledged computer or full-fledged server. And inside that virtual machine, we can install operating system, we can install applications, we can execute applications, and whatever we do on a normal hardware, we can do inside a virtual machine also. Only difference is physical server we can see, virtual machines we cannot see physically. That is the only difference. Okay, so that is a virtualization concept. See here, what we used in traditional data centers, I have one hardware, I have one operating system running on top of that, and applications running on top of that operating system. This OS and application can use 100% resources available on that hardware. Now coming to virtualization, which is represented on the right side. Instead of running operating system, we will run something called a hypervisor on top of your hardware. Okay, so VMware hypervisor is called ESXi. So we'll run VMware ESXi on top of that. It can be any vendor, even KVM, maybe the hardware hypervisor. Maybe you can use Microsoft Hyper-V or any other vendor hypervisor platform you can run. So that will be executed directly on the hardware. Then on top of that hypervisor, we will create virtual machines. Each layer you see, those are individual virtual machines. On each virtual machine, I can run its own operating system. Maybe the first virtual machine I can run Windows, second one Linux, third one another vendor, another version, another OS we can run. Like that, I can get multiple virtual machine. I can install with OS, and I can install applications. And these all virtual machines are isolated. What is happening on machine 1 is not visible to machine 2. So this is the virtualization. Any question here?
Yeah, no questions.
Okay. So now coming to the next section, let us see. This virtualization will avoid any of the problems which we discussed before. Okay. So what we see is maximum resource utilization is happening. How the maximum resource utilization is happening? Already I explained you. When I create multiple pools, the utilization on that server is increasing from 15% to 30%, 45%. When we keep adding more VMs, the resource utilization will increase. So if I create 5 virtual machine on one hardware, that means I'm reducing 5 hardware to one single hardware. And I'm increasing my resource utilization on one hardware from 15% to maybe a 70% or 80%. We normally don't run 100% because the resource utilizations will go up and down. So we'll keep some margin, some extra bandwidth free, so that when the resourcing requirement increases, still he'll be able to manage with the available resources. So we see here the resource utilization is increased. Then reduce hardware cost. Of course, when 5 hardware is required, I managed it to run it in one single hardware. I'm reducing my cost of data center 1 by 5. Right, 5 lakh is required, but now I can do the same thing with 1 lakh rupees. Now coming into less cooling requirement. When I use less number of servers, I need less cooling system because less heat is produced. Less power consumption is required in this case because I have less AC, less hardware, so I just need less power. Again, less space consumption, less carbon footprint. All those problems are rectified. Now coming to no vendor lock-in. How is it possible? What was the problem before? If I want to run Solaris, I need a Spark machine. But now virtualization says there is no vendor lock-in. That means you should be able to run Solaris on virtualization on a Intel hardware. Correct. So that is possible in virtualization. I can run other hardware required softwares on a Intel hardware with the support of virtualization platform. It doesn't mean that anything you can run on virtualization platform. Okay, there are supported OSs which can be executed on top of your virtualization. How is it possible? If, for example, if I'm taking Solaris as an example, Solaris will be sending Spark instructions. So those Spark instructions are getting forwarded to the hardware, and hardware will be executing it. But when it comes to the virtualization, what happens is the Spark instructions will be forwarded to the hypervisor. Hypervisor will translate Spark instructions to corresponding Intel instructions, and it will be given to the Intel hardware. Intel processor will execute it, and the response will be given back to the hypervisor. Hypervisor will translate the Intel responses to Spark standard of responses, and he will forward to the operating system. Got it? So this is how the vendor lock-in is avoided in virtualization. But again, I'm repeating it. Doesn't mean that you can run anything on the virtualization. Virtualization have a set of softwares which is supported. Those softwares you can run in virtualization platform. Now coming to faster provisioning. So we saw in traditional data centers, we are taking 2 to 3 week time to do a provisioning of services to the customer. But when it comes to the virtualization, we saw that we have virtual machines. So once we create a virtual machine, we can keep it as a standard for building later virtual machines. And what we can do is anytime a customer coming with a similar requirement, I can just clone one virtual machine from the standard one to a new one. So I can clone one virtual machine to new virtual machine. So this cloning hardly takes 3 to 5 minutes, depends on how big is the VM. So what we are doing, a provisioning time, we are reducing from 3 weeks to 5 minutes. Okay. And if you have any, right, companies will have process, procedures, approvals, right, all those things. Including all those together, hardly you will be able to give the service to the customer in 1 or 2 days time. So that is a bigger improvement from the traditional data center problem, right? So these are the problems with the data center, and we saw what is virtualization, and we saw that okay, all those problems we faced in traditional data center is rectified using our virtualization technology. Any question till now?
Yeah, no questions.
Okay. All right. Types of virtualization. So virtualization, we discussed what is a virtualization. We have some resources, we are pooling it, and each pool we are giving to one customer. So what are the different areas in which we can apply the virtualization? Based on that, the virtualization technology is classified. You can see in the picture, we have a storage virtualization. Storage virtualization means I have a pool of disk space. We are making chunks out of it, and we are giving to different customers. So that is a storage virtualization. Then server virtualization is there, desktop virtualization, application virtualization, network virtualization. So different type of virtualizations exist. Now I have a question. In when we started, I said IBM came up with a memory virtualization concept where they were having less RAM, but they were able to utilize it like 16 GB of RAM, right? More RAM. Can we do that in our server storage and other stuffs? That means I have 2 TB of storage. Can I allocate 4 TB to my customer? Is that possible?
Not possible.
I have maybe a CPU of 4 gigahertz. Can I allocate 8 gigahertz to my customer? Not possible.
No, virtually you can make it, right?
Yes, that means can we allocate? That is the question. Whether
Yeah, we
we
can.
utilize 8 or not, there is a difference. Yeah, we can.
Yeah,
Right?
we can.
Yes, we can. So we can configure more resources to the virtual machines than what is available actually on the hardware. So that is the benefit of virtualization. Why it is a benefit? As a data center provider, I have only 2 TB of hard disk space, but I'm configuring 4 TB for different customers. So that means I'm getting paid for 4 TB of disk space, but I spent money only for 2 TB. Then when it will be a problem for me? Maybe after some time, maybe months or years later, right? Because even when you purchase a laptop, I told you we have only 30 GB of hard disk is utilized for operating system and basic applications. Then what we'll do, we'll copy different things over time. Maybe some movies, maybe some other data, maybe some photos we'll copy, and it will take years to reach up to 1 TB. So similar to that in data center also, over time, the hard disk utilization will be keep on increasing. When the overall disk utilization reaches to 80% of what is available, that is maybe somewhere around 1.6 TB of disk space is utilized, that time I can invest for additional hard disk and I can add to the storage. So till that time, whatever amount I'm getting from my customer, which is free for me, right? I'm not spending, but I'm getting benefit out of it. So that type of provisioning, that means provisioning more than what we have, is called overcommitment. Overcommitment is a feature of virtual. Okay, we are telling to the customer that I'll give you this much, but that is more than what I have. Okay, so these are the type of virtualization. Now we saw that all the problems are resolved. It is good, virtualization is good. But now, because of virtualization, we are getting many additional features which was not available on a traditional data center. So let us see those features. Few features are these things. Encapsulation. Encapsulation means we saw that there is a virtual machine we create. If you look into the virtual machine deeper into the storage level, it is simply a folder. A folder consists of multiple files, which actually makes our virtual machine. So that is what we call it as encapsulation. A virtual machine is encapsulated inside a folder. Okay. So whenever you want to move that virtual machine to another place, another separate data center, what you can do is you can simply copy that folder, or you can export that virtual machine into a pen drive or something, and you can take it to another data center, copy there, and you can start that virtual machine on a different network. Okay, so that is encapsulation. Then overcommitment just we discussed. We can allocate more resource than what we have. Then coming to virtual networking. In traditional data centers, if I have 10 server, I need 10 network port to connect them to outside world. Now in virtualization, even if I have 10 virtual machine inside my one single server, these all virtual machines will get something called a virtual switch inside the server itself. So you can make all the network configurations to make these VMs to talk to each other or isolate them using VLANs or something. All those things we can do, and we need one single port connectivity to the physical network, physical switch. So because of using this virtual networking, we are saving a lot of money in the hardware switches. So that is one benefit. Then coming to templates and cloning. So we already discussed what is cloning. I can make one copy of a virtual machine using cloning, and template is the standard virtual machine which I was talking before. We can mark one virtual machine as a template so that no one can modify the content, so that we can keep it as a source for cloning the new virtual machines. These all we'll see when we do the detailed sessions. Snapshot. One problem what we are facing in servers or any operating system is when we do the OS patching and all, we may see the server is crashing, right? So in virtual machines, what we can do is we can create something called a snapshot, that is an in-time copy of your virtual machine. It will make a snapshot for that time, and whatever changes we are doing, anytime we can skip those changes, we can reject those changes, and we can go back to the snapshot. That is possible in virtual machines. Then coming to vSphere data protection for your data integrity and backups, all those things use vSphere. Then storage provisioning is possible. That means we have a pool of storage. We can carve out a specific area of the storage and we can allocate it to individual virtual machines. And there is something called VMware vSAN. This is VMware's own product, and this is very much benefit for small data centers. Normally, one main cost involving area on a data center is your storage. Normally, we will have a storage device which is specifically for storing our data, and there will be a specific network for connecting your server to storage device. That is a SAN network. But VMware came up with a virtual SAN concept in which we don't need external storage. Instead of that, what we do is, if I have 5 server, I will take their local hard disk and I will club them and it will send it to the servers as one single storage. So the benefit is, even if one hard disk crashes, your data will not be lost. Even if one server crashes or 1 or 2 server crashes also, your data will not be crashed. All right. So virtual SAN, we are clubbing multiple servers and we are pooling the local hard disk, and we are creating a single storage and it is presented to servers. So failures of single or single hard disk or single server will not impact your storage. Okay.
So
You know
virtual
this
SAN,
concept, right? Tell me.
yeah, virtual SAN is like a concept of using storage internally in the VMware, or it's related to network.
This can be utilized like your normal SANs. We can present it to like how you do. You have a external storage device and you are presenting the lunch to your servers, right?
Yeah.
Same way, once you pool your storage, it can be given. It's one vSAN can be carved into small portions and you can submit it to the servers.
Okay. Through
It is
vSAN.
available for. Your question is, can we allocate this storage to a third server? That is your question, right?
Yes.
Yeah, that is possible. Okay. So this concept we normally call RAID, right? When we have multiple disks on single server and we are clubbing them, we call it as RAID. And this, when we combine multiple disks, which is part of different servers, we call it as RAIN, redundant array of independent nodes.
Okay, I got it.
vSAN uses a concept called RAIN.
Yeah, vSAN. I thought vSAN means it's like a virtual. SAN means fabric, right? Storage area network. So I thought it is a virtual
No,
network.
no, it is not a network. It is not a network. It is actually your storage space. Like RAID, we club multiple hard disks to one pool. Here we are clubbing disk, which is in different servers. That is only difference.
Okay.
It's a storage space. Okay. So now coming to vMotion. This is something not available in other traditional data center. vMotion means I can move one virtual machine running on one server to another server when that virtual machine is running. That means you assume that you want to do some maintenance work on server where a VM is running. What you can do is you can vMotion. You can move that existing VM from that server to another server, but the VM will be running. If a customer is working on that VM, they will not even know that there is some change is happening. That means there is no service interruption. This is not possible in your traditional data center. If a server you need to maintain, you have to go for a downtime, right? But here that is not required. You can move VM to another server. You can do the maintenance work. After finishing the maintenance work, you can bring the server back. Then you can move the VM back to that server. It is possible. That is called vMotion. Similarly, we have something called a storage vMotion. Similar, I have two storage devices and I have my virtual machine files are running on stored on one storage, and you want to do some maintenance. What you can do is you can move your files from your one storage device to another storage device, but still the VM will be running. There will not be any impact, and you can do the maintenance work and you can move the data back to here. So simply, there is no service interruption when we need some maintenance or some other activity in your data center. Okay, so that means we are reducing the downtime in your data center when we use virtualization. All right, so only possibility for a data center to go down if you are properly designing a data center is when there is some natural disaster is happening, some earthquake or flood or something is happening, then that we cannot control, right? So that is the only chance for a data center to go down. For that also we have a solution. We can have a DR site, disaster recovery site. We can keep another data center in a different place and we can sync between these two data center, and when primary data center goes down, we can bring the secondary data center. Okay, so now coming to physical to virtual conversion. This is assume you have a traditional data center, you are now started deploying virtualization. Now what happens to your existing data center, existing physical servers? You can convert your physical servers to a virtual machine. There are softwares available called P2V and all. So using that, we can convert your physical machine to a virtual machine. So it is not like, okay, I already have physical servers, I cannot do anything. I have to run physical servers and virtualize servers for lifelong. That is not a requirement. Then coming to clustering. Clustering is a concept we use in virtualization to club multiple servers, and we can add extra features to clusters like high availability, fault tolerance, DRS, DPM. These all features will be enabled on cluster that we will see later in detail. So on-demand, non-disruptive capacity. That means if you feel that your data center need more resource, you can keep on adding server. When you feel that okay, your servers are more, you don't need that many servers, you can shut down multiple servers, but still your data center will be working fine. There will not be any service interruption. That is not possible in traditional data centers. High availability is if your server crashes, a VM is running and your server is crashing, those VMs will automatically get restarted on another server. So downtime will be there for a short time. We need not to go and see, okay, it is down, we have to restart. Those things are not required. So this will give you 95% uptime. Then we have something called a fault tolerance. Fault tolerance means even if your server crashes, fault tolerance maintains 100% uptime. That is 99.999% uptime will be maintained if you enable fault tolerance. That means your server crashes also, your VM will not go down. Okay? We'll see internal details later when we discuss it. Then we have something called a DRS, distributed resource scheduling. If you have 10 server running and use your VMs can be run in 8 servers, then the DRS will automatically move all the VMs to 8 servers, and 2 server he will shut. Sorry, that is not DRS, that is DPM. Okay, so distributed resource scheduling, what it does is assume that I have 10 server and one server is having higher utilization and another server is underutilized. One server is at 80 to 90% utilization and another server is somewhere around 10% utilization. Then what DRS will do is he will do the balancing of resources. He will move few VM from overloaded server to the underloaded server, and he will maintain a balanced resource utilization among all the servers. That is a DRS. So it will make sure that the better performance is happening in terms of execution of applications and all. Then we have something called a DPM, distributed power management. So distributed power management is assume that you have 10 server and all the load running on the 10 server can be managed with 8 server. In that case, DPM will move all the VMs to 8 server and he will shut down two servers. That means we are saving power cost and cooling cost on those 2 servers. And whenever the resource requirement increases, this DPM will automatically detect it and he will start additional servers. So on demand, based on the resource requirement, the DPM will power on new servers or power off existing servers, and he will maintain optimum utilization in the center. That is a DPM. Now coming to disaster recovery. Disaster recovery, just we discussed. We can have a secondary data center and we can sync between those data centers. When the primary goes down, we can enable we can bring up the secondary data center. Those kind of data center we called as DR site, disaster recovery site. Then another thing is access control and user management. On a data center, we may have hundreds of administrators. We cannot give full privilege to all the administrators. So VMware provides access control and user management in which we can give different privileges to different users and different level access we can provide to them. That is possible, which is a safety concern for our data center, right? That is possible. Then we have something called a VMware Update Manager. Update Manager is a software component for managing your data center patching, upgrades, all those activities. So instead of going to each and every server and doing the patching and upgrades, you can configure this VMware Update Manager. He will automatically pick servers one by one, and he will do the patching, and he will make sure that servers are patched completely. So we can start the process and we can leave it like that. It will pick one by one, and he will finish the patching process. So these are the additional features, few we are getting because of virtualization. In the sense, this is specific to VMware virtualization. If you take another product, they may have their own set of features. Okay. So any question here? On any of these feature? No. Okay. All right. So I told you, we discussed before, hypervisor is the main core component which makes this virtualization possible, because that is the one which is running on top of the hardware, and hypervisor is actually hosting all the virtual machines. So coming to hypervisor details, we have two type of hypervisor. One is bare metal hypervisor and another one is hosted hypervisor. Till now, whatever we discussed is about bare metal hypervisor. Bare metal hypervisor means you have a hardware, you have a server. On top of that, you will install your hypervisor and you will host your VMs. And this is the one which is used in your data centers. And we have a second type for your testing purpose, learning purpose, POC purpose. You don't want to invest on more hardware. Then in that case, we can go hosted hypervisor. Hosted hypervisor means when you have your laptop or you have your normal desktop, you can you have your Windows operating system or Linux operating system. On top of that, you can install a hypervisor like VMware Workstation in case of Windows or Linux, or in case of Mac OS, in case of Apple laptop, you can use Fusion. So, or you have VirtualBox. So these softwares you can run on an existing operating system, and inside that you can create virtual machines. And this is not used in data centers. Why? Because your hypervisor stability and performance depends on your underlying operating system also. So that is not good for a production setup. That is why this is used for your learning and testing POC purpose, and your bare metal hypervisor is used for your production setups. And all our discussions will be based on your bare metal hypervisors. Okay. Now coming to the software, VMware, almost every software we are getting a 60 days evaluation version. 60 days means almost 2 months. I think it is more than sufficient for doing all the practices and complete it. Right? So we'll get free softwares available from VMware. But only problem is we need a good resource hardware for setting it up and using it. All right. So now coming into the exam, I told you we are covering DCP DCV certification or the course content. So that course is VCP DCV is the course name. Exam code is 2V0622. Exam consists of 85 questions. Passing score is 300 out of 500. And 100 minutes is the exam duration. And exam cost is $225. I'm not sure the cost is changed or not. It is almost like 6-month-old information. I believe it is same even now. Okay. So this is about the exam details. And that's all